4.10, number 500. We have f prime of x equals the root of x plus x squared. But we don't just have the derivative of a function, we have an extra piece of information. F of 0 is 2. Okay? So this is called an initial value problem. The reason it's called an initial value problem is because you have some information about the function, right, f, at its initial point 0. Right? It doesn't have to be 0 necessarily. You'll see some of these problems don't have 0 in here. But it's usually called initial value because the value tends to be 0, which is some sort of initial value, a starting point, usually for some physical quantity, right? So it could be time starts at 0. Time doesn't start negative, right? That's the most common case. But any other physical quantity that would not start at negatives tends to start at 0, of course. And so now we know the function's value at 0 at the initial part of this. It might be some sort of applied physics problem or something, right? So f of 0 is 2. So maybe at time 0, if this function is distance or displacement or something, maybe he's 2 miles away from a certain location at time 0. Something like that is the general idea. So what we're supposed to do is basically find f as a function. Find f of x. We only know it at one location. We know f of 0 is 2, but we also know its derivative everywhere, though. So in a way, it's a bit abstract, but in a way this is like finding the equation of a line. You think about when you find the equation of a line, right? The usual information you're given is a slope and a point. Now, because a line has a constant slope, when they give you the slope, it's just a number, right? So this is similar to find y equals mx plus b, where m is known, right? You know the slope, and p is a point on the line. This is just an abstract version of this, right? Because look at the information they've given you. What do you have? You have a slope. That's what a derivative is, right? Slope. Now this is a changing slope, right? F has a changing slope, and that's why its derivative is so complicated and it has variables in it. But back over here, when you're dealing with a find the equation of a line, they give you a slope. It just happens to be a constant because a line has a constant slope. So over here, they're giving you a slope and they're giving you a point. It's really the exact same type of problem. Only now you're going to find a curve, right, an actual curvy curve, as opposed to a linear curve. And what's making it curvy is the fact that the derivative is variable and not constant. But in theory, this is all the same type of problem. We've just bumped up a level of complexity because now we have non-constant slopes. Okay? So we want to find f of x. So we should take our antiderivative, right? I'm trying to get from f prime to f. So I should find the antiderivative of f prime. So we'll just put this in here, root of x plus x squared. We're going to reverse this process. In other words, we're going to strip away the derivative process that occurred by doing the antiderivative process, and this will put us back to the f function. So we can apply the sum difference property, and I'm going to also write root x as x to the 1/2 simultaneously. We want to see it as a numerical power, not as a root, so we can apply the reverse power rule, and then plus antiderivative of x squared will also deserve a reverse power rule. All right, so keep moving, and we have 1/2 is going to go up to 3/2. So we'll have 2/3 x to the 3/2, right? Raise the power up by 1, multiply by reciprocal of new power. So 2 for x squared up by 1, and reciprocal of new power on the front. So this plus c. Okay, so this is f. because we just undid, right? This symbol, the integral symbol with dx, undoes the derivative operation. They are inverse processes. So this is f of x over here, right, at the moment. But we don't know what c is. And this is a general antiderivative for this expression here. And f of 0 equals 2 will now allow us to find c. That's really its purpose in this problem. So we just apply what they say here, that f of 0 is 2. So f of 0, if I put 0 into what I'm calling the f function at this point, I would have 2/3 0 to the 3 halves plus 1/3 0 to the 3rd plus, I don't know what this is yet, has to all equal 2 according to what it said here. All right, so now we just solve for c. Well, in this case, it's very simple. These cancel out totally, and c is 2. Not always that way, so don't always assume it's going to be the value c here. It happens to be because this value is 0 here, and the antiderivative is simple enough that c is 2 itself. Okay? So now we have the function totally known. Again, just like when you have the slope known and a particular point known for a line, you can write out the equation for the line for all points on that line. So to here we now know the equation, you might say, or the rule for this function for all points on this function, not just one. So looks like the function was in reality 2/3 x to the 3 halves plus 1/3 x cubed plus 2. There's our answer.